So first, a show of hands. Who here has seen the Oscar-nominated movie Everything Everywhere All at Once? Wow, that's much better than I expected. And the other question, how many of you have seen Hinek Šlavak's talk, Design Pressure, from yesterday? All right, so I should warn you that this talk is a little bit of the other half of the talk that's focusing on the examples and the specific named library that concerns it. So be warned. My problem statement is very simple. Pydantic is amazing, and I love it, and I love to use it everywhere. It's good everywhere you need an interface that needs a validation. But every interface is a little bit different, even though the underlying object that you're trying to model is kind of the same. So can we do writing Pydantic code without duplication, and should we? Is really the question of the hour. But before I jump straight into that, let me introduce myself a little briefly. My name is Šimon. I used to do neuroscience. Now I don't anymore. These days I do large language model evaluations on the application layer and all things data around it, because there's quite a bit of data engineering and data science needed around it these days. I work at a tiny company called Waypoint AI, and I have grown to use Pydantic in most places, including some places where perhaps I shouldn't. And the talk is a consequence of me shooting myself in the foot repeatedly. So I mentioned that there are a lot of interfaces that you can use Pydantic within. And I'm not going to be able to cover all of them, so I just picked the 3 that I'm most familiar with, and the 3 that I think are most common. Number 1, and I think you all can guess, is FastAPI. It's the de facto backend standard, and there you use Pydantic for, among other things, the main 3 things: sanitize the inputs, constrain the outputs, and provide a JSON schema to the user so that they know what to expect when handling your backend. Then there's LLMs, which honestly, structured outputs, for those of you who don't know, structured outputs on LLMs are when you tell the LLM, don't just give me anything you want, give me these fields, and within those fields give me these types, and within those types give me this meaning. It's a lifesaver for me. I love structured outputs. And for structured outputs, the de facto standard, again, has emerged to be Pydantic. There's this library called Instructor by the inimitable Jason Liu that I like to use. But for the most part, you can do this with the raw OpenAI client, right? You can provide field descriptions and examples, and they will go in the JSON schema that's sent along to the OpenAI API. You can do sanitization of the outputs of the AI API. And you can do retry on failure, where you supply the validation errors that Pydantic gave you back to the AI. So it can correct its own mistakes, which is something that I find very handy. And finally, ORMs. Now, in this presentation, I mostly talk about SQLModel because it's my favorite. I know that there are some emerging alternatives. But I think my presentation applies to them as well. This is just a convenience. On the database layer, you have the ability to define both your database table structure and the object structure in the same place, which makes for a little bit of dry code, though we'll talk about why dry is perhaps not the best thing to aspire to. You can auto-generate migrations, and you can do advanced validation that perhaps your database can't. So the temptation here, of course, is to put sort of everything into the single object, a God object, and everything bagel. And we will take a look at why that fails and what other alternative approaches there are. So let's see about the everything bagel, right? So in this presentation, throughout the presentation, I'm going to be handling an object called bagel order. and we're going to be running a fake backend API that handles bagels. This is, of course, my only nod to the movie, because I just really liked the pun, and I had to watch the movie the weekend prior to make sure that I've got the pun right. So, the God object. The problem with the God object might, at first glance, appear solvable, right? You've got the bagel order, you've got the things that are public about it, like the customer name and the bagel type and the quantity of bagels, and you've got some private fields, like admin nodes. And here, you can overcome a little bit of a problem that perhaps FastAPI users shouldn't see, that you can add admin nodes, and perhaps OpenAI should not attempt to add admin nodes, with a little bit of something called skip JSON schema. Now, this is fun, but of course it fails, and I'm going to show you how it fails in a little bit. Right, I've got the OpenAPI example ready. Here I'm just going to execute it, and at first glance everything works. I get the response back with the right ID, with the bagel type, without the admin nodes. Of course, the problem is that skip JSON schema is not magical, right? You can add the admin nodes. Right, let me make this bigger. Sorry about that. And if you run it through, you will not only have made the admin nodes without any complaint from FastAPI, you will also get them back in the return object, the God object, the same object, the everything bagel object. So maybe skip JSON schema is not the savior that we have been looking out for. And of course, the problem is that you have to set the database ID. You don't get any nice affordances from the ORM. You can either wrap this all in SQLModel, or you cannot do SQLModel at all. And also, you might want the JSON schema of FastAPI to include something that the LLM schema should be missing. For instance, maybe the users of your backend are the people who are actually running the cache machine, but the users of the LLM are just agents who are satisfying people's hankering for bagels. So those shouldn't see admin nodes, but the people handling the API should. So let's take a look at the other option, the next natural option, which I call the inheritance matryoshka. And I'm sure you've seen this pattern, in part because it's prominently featured in the documentation of both SQLModel and I think FastAPI. You sort of have a base object that has all the public fields, and then you inherit from it to make a database object and the creation object that FastAPI will accept, and then the read object that FastAPI will serve in return. And you might, if you can read tiny letters, you might see the fix me at the bottom, which actually explains that this will not work. The reason why this is a problem is a couple-fold. One, you can inherit to SQLModel, but you sort of cannot inherit from SQLModel. Because if you have table equals true on the SQLModel, every other subclass will also try to create a table for itself. So even if you have the object that's bagel order read that inherits from the database, even though all the fields are the same, you cannot quite work with that. The other thing, of course, is that if you want to add fields, you have to be very careful about where you're adding the fields to, right? If you add them to the base object, they will proliferate to everything else. You might need to run a migration as well, because suddenly there's a new object that should be saved in the database. if this is a sort of a semi-private, semi-public object, semi-private, semi-public attribute, then you might need to add it on one subclass but not the other. It's a little bit of a mess. That said, I don't think that this is such a huge anti-pattern. I think that there are projects where this is great, or at least where this is tolerable, especially if you're just starting, especially when you're trying to move fast, especially if you don't expect the project to last very long. And I'm just going to quickly move to the matryoshka API. I'll run the take one, and here I discover that it's actually failing. It's failing for the same reason that we identified in the slide, which is that there is a bagel order DB inheritance to bagel order read, and suddenly SQL Alchemy is confused. I have a fix ready where you just have to rewrite the bagel order read to inherit from bagel order base and then redo the attributes anyway. And so that would work, but it's a little unpleasant, again, because you can't quite rely on inheritance all the way across all your Pydantic auxiliary libraries. So what's next? So you might figure that maybe we should just bite the bullet wholesale, right? Maybe we should do a thing where we just have all the interfaces and we have the internal object and we treat them fully separately. And I think that's actually probably the cleanest solution that we have available, right? You can have a domain class that's internal that carries all of the objects. You can have slots. If you don't know what data class slots are, go to REstock, I think on tomorrow. But basically it makes the data class faster and it takes away some of the dict capabilities from it. And you can have the API objects that are treated separately. You can define them fully separately. You have to maintain them fully separately. But perhaps that makes sense because we've already come across many attributes that have separate meanings, separate descriptions, separate visibility, and separate validations in each and every interface. And of course, one thing that you need to take care of in this case is the mapping between the classes. But the mapping is fairly straightforward, and I can just refer you to the model validate class, where you basically dump the class, the base class into a dict, and then the magic of serialization and deserialization lets the data class take over. You might need to write a mapper if you want to be more specific about the privacy of your attributes, but that's also quite straightforward. What's wrong with this? Mostly that it's a lot of work. It's neither dry nor wet. It's some other third thing that's the more inconvenient, the more interfaces you have. But you do have full flexibility in how you treat everything. You can add separate field descriptions for the LLM to generate the right description of a topping, and a different description for the ORM so that the database table makes sense. You can have different validations at different stages. It makes a lot of sense, right? My final spicy take is that there's one other way, and I'm not sure I would recommend it. I call it the over-templated approach. And it might be upsetting and possibly disgusting to some of you, for which I apologize. But basically, you generate Python code from a JSON schema. It's very unpleasant. I would not want to do it. And If you visit the repository that I prepared for this talk, you will notice that this take actually stayed on its own branch just because I couldn't make it fully work in the time that I've allotted myself for trying this out. But basically the idea is that a JSON schema is very flexible. You can have specific properties like XLLM description, that's only the LLM instruction. You can have actual description that would go in the database or the Pydantic object or the docstring. You can specify things as read-only or primary key and then deal with these fields separately so that they automatically don't go on the input schema but do go on the output schema. There's a lot of flexibility. So what's the pain? The pain is Jinja and the fact that you have to template everything separately. There's a library called Data Model Code Generator, which is amazing for what it does. The library helps you make base classes for Pydantic 1 and 2. It helps you make data classes. It helps you do type dicts and struct blocks and all the other outputs. You can also make custom templates, which you need because SQLModel needs to process type hints a little differently if you want any more complicated objects to be handled properly. It's a lot of pain. Now, the first question I got when I pitched this talk was, Simon, you're an idiot. Why aren't you using an LLM to generate code? And I think that's a fair criticism. The answer is maybe you should do that. If you don't have to maintain the APIs across many languages, for which code generation starts to make a lot more sense, right? Maybe if you don't need to check that the API remains the same across all of the generations, but perhaps you might want this data model code generation to be a part of your continuous integration and check that nobody forgot to regenerate the generated schemas. But once again, if you have a project that's reasonably large, but that you don't expect to change all that much, then maybe you should forget all about what I'm saying and just throw an LLM at it. Although if you're going to prompt it well and prompt it thoroughly, it's probably going to start looking a little bit like a Jinja template, at which point you might as well. I promised a decision tree, and this is a teeny tiny decision tree. So just let me recap and then provide more space for questions. If you only have one interface, and if you just carry the same data across it, it might make sense to have the everything bagel, the God object, because at that point you don't have to deal with all that much. You can probably use the magic of skip.json schema. You can probably have a custom validation that just takes out that property at creation time, that sort of thing. That might make sense. If you have multiple interfaces, but the differences between the interfaces are mostly about privacy and strictness, it might make sense to do inheritance. If there's anything more complicated happening, if you have to instruct an LLM and label your database properly, but you don't have to generate for multiple languages, it might make sense to do separate domain object and interfaces or schemas. You might notice that if you are coming from a different language, I seem to have rediscovered interfaces and called them something else, for which I apologize. And finally, if you have a large project, a project that perhaps needs to be served across many SDKs in many languages, where you need to regenerate the schema regularly, it might make sense to actually have a central JSON schema that you regenerate the code from. With that, I think I yield myself to questions. If you want to see more code, there's a QR code, and I will also link this in the Discord. If you want to see more food guns and shitposts, my LinkedIn is always available to you. And I thank you so much for showing up in such great numbers, and I'm looking forward to your questions.
Thanks. So we have plenty of time, and there is a big audience. I'm sure that many have some questions. So there is a microphone there for those. I'm happy to lend the microphone here if somebody has a question. Yes, coming. I'm slow, sorry.
Okay, thank you for the presentation. I'd like to ask, how do you tackle, or if you ever tackled like the issues with inheritance, even when you like define like some Pydantic classes or like the data classes in domain? You still like have some cases when you need only like some attributes. You have like, okay, for creation, for manipulation, one method needs only some part of data. So I think that even when you like separate like the classes and from the schemas, models, database models, and domain, you can still have like some the inheritance hell. So did you tackle this issue, or?
Honestly, I tried not to, mostly because when you run into inheritance hell, the first instinct is to run away. When you do decide that you want to go for the inheritance approach, I think it makes sense to create the methods on the class or subclass that is being acted on either the most or on the superclass if all subclasses are being acted on. But honestly, I think at this point I'm trespassing on like the Bibles of object-oriented programming, and I'm not sure I'm quite well read on those. So I think my honest answer is I'm not sure. It depends on the case.
Thank you.
Any more questions, please? We have time. Don't be shy.
Okay. You said you quite like SQLModel, but you also said SQLModel doesn't mix well with others. And the benefits you listed for it as an ORM seem to be mostly SQL Alchemy benefits. So what's the big sell for SQLModel?
Honestly, just that I ended up going down that rabbit hole the most. I'm currently trying to explore Tortoise and using the ORM mode in Pydantic proper. Perhaps this will remove many of the drawbacks. But sometimes you run into libraries that run mostly on Pydantic version 1. And you might not know that until you try to mix them. And it's good to be wary that that can happen. Thank you.
More? Anybody else? No? Well, let me ask you just one last question, maybe. What was the before using Pydantic, what was the, I mean, I wondered what was your reaction when you first discovered this library that could actually open so many like rabbit holes and so on? What were you doing before?
Before Pydantic, I was writing a lot of type checks myself. I was also an R user, so that comes with its own separate can of worms of having data frames within data frame columns and all that jazz. I was also not using Python type hints nearly as much as I should, because while I think type hints are useful even without Pydantic, I think that type hints help the static checks in an era of LLMs. They help the LLMs self-correct when writing code and dealing with your code. I think type hints are amazing when it comes to Pydantic. So that's my primary motivation. But I have to admit that I had to be forced into it. I joined a company that used Pydantic, and I was an instant convert. But before then, instead of a sequence of Pydantic objects, I probably would have asked, why don't you use a data frame? And for that, I apologize.
Oh, good, good. So we have You have 4 minutes for your question.
Thanks for the talk. I kind of don't understand in a way what you're struggling with, because why not have a simple structure or class with, you know, a flat definition of all your data that you process? Because in a way, there's no guarantee that the model will respect your data structure, right? So you want to check it anyway. So why not reformat it afterwards, depending on your need?
I think I disagree that the model will not guarantee that, for instance, additional properties aren't provided at the validation time. So I think it makes sense to have fewer attributes that are public on one model and expose that, and then have more attributes on a model that's private and use that internally, and sort of do validation on the edges and then actual full use internally. I think the privacy and the validation are the most important reasons there.
So, chiming off that in a weird way, I'm thinking back to a previous talk by Henrik. Had you considered the awful idea of having sub-objects that you inject that have the bits of information you don't want to be public, and you only put them there when they're needed?
Oh, that's interesting. So the objects that are being injected into probably the domain model, that would be sort of
your ORM would gain extra objects that are ORM specific. Your data, your sort of internal stuff, your order status will only be injected when you.
I have to admit, I hadn't considered that.
Probably shouldn't, I'm thinking, but
that was my next thing. Yeah, I think that probably couples things that shouldn't be coupled.
I think
in
that's
just the same
back
way.
to one of Heinek's key talks in the past, but it's an idea, certainly.
Yeah, thank you. I will investigate and shoot myself in the foot and report back.
One last, okay. Well, couple, if you want.
I might have an understanding question. So towards the last take 3 that you proposed, how is the validation working there in this JSON schema? So how can you ensure that you have the same model validations in place there?
So this idea only works for the basic type validations. I think that if your objects on the edges, if the interfaces need to do any more advanced validation, there's probably some additional magic that needs to happen, maybe subclassing from the generated class, and defining the validations there for stuff like if you have multiple properties and they all need to be floats between 0 and 1, but all of those properties together need to sum up to 1, that sort of thing. But yeah, I think the generated code handles the validation, and the JSON schema itself just says what the validation ought to be in terms of types, possibly in terms of some agreed upon properties like smaller than or greater than numbers. I have to admit that I did not go deep enough into the guts of the data model generator to see how much of your own things you can inject at runtime. Thank you so much for your questions.
Yeah, great discussion. So let's thank Šimon once again, please.